You are currently looking at a quantum object. This isn't science fiction or some kind of optimization trick. This is a house generated by a D-Wave quantum computer in Minecraft. All of this was done using a process called quantum annealing. In this project, Andrew and I are going to show you how this house was generated, how quantum annealing enabled it, and all of the challenges that we faced along the way. The goal of this algorithm was to create procedurally generated villages in Minecraft. This has been previously done on YouTube by Jabrils using a procedural generation algorithm called waveform collapse. Waveform collapse handles all possibilities simultaneously in an array. If a possibility is selected at random, it updates its tables of legal possibilities, and when only one remains, the algorithm is done. We wanted to create a similar penalty-based algorithm, but have it be faster. In order to define our algorithm, we need to define quantum annealing first. Quantum annealing is fundamentally an optimization technique. It uses quantum phenomena to optimize a problem called quantum unconstrained binary optimization, or QUBO for short. To use a quantum annealer, we must specify a Q matrix. The Q matrix encodes our problem into something called a QUBO formulation. Then we send our QUBO formulation to a D-Wave quantum computer on the cloud, which returns us our house. To make a formulation, what you really need is a penalty function. The way to make a penalty function is to have a set of rules, and whenever a rule is violated, you increase the value of this penalty function. This means that the minimum energy state for a formulation is 0 under ideal conditions. This is a good way for us to check if our house is correct or not. To create our rules, we had to create several quantum logic classes, which return a penalty when its conditions are not fulfilled. You can think of these kind of like as assembly instructions on a classical computer. As for Minecraft, we had to save our structures in a format called NBT. The way to do this was to take our encoded house and write it to an NBT file and then put it into our Minecraft folder. Once we have this, we can use structure blocks to load our house in Minecraft. Overall, the main accomplishment we had for our project was achieving our end goal of generating quantum houses based on a rule set, and the houses didn't look that bad either. Our algorithm was able to run on a real quantum computer by a company called D-Wave. Some challenges we ran into were that our data pack was difficult to debug and did not work, that Minecraft did not have any item IDs recorded, that quantum logic works much differently from classical logic, and that quantum computers are memory limited, so we can only have certain very basic blocks and houses of limited size. Thank you for hosting this hackathon, and we had a lot of fun.